Greetings, fellow travelers. The other day, I got to thinking about dice math. You know, probabilities and whatnot. And it occurred to me that there's a die, or rather a set of dice, that I've been staring at since I started playing TTRPGs, but don't really know how they work, mathematically speaking. Percentile dice. I've used them, sure, maybe once or twice, ever, but never thought too much about them. Well, it's time for me to think too much about them, because understanding how dice work makes us better players, game masters, and game designers. So, if that interests you, then come along for this short dive into the wonderful world of dice math. Every standard D&D dice set, the ones you get in those little plastic Chessex containers, comes with 7 dice, a D20, a D4, a D6, a D8, a D12, and 2 D10s that are marked differently. One is 0 through 9, and the other is 00 through 90. These are your percentile dice. They basically allow you to roll a D100 without needing a real 100-sided die, which even if you do have one, it takes forever to stop rolling. One die is the ones place, the other is the tens place. You roll them together and add their results. So just like how Dungeons & Dragons uses a D20 as its standard die for most actions, plenty of games use percentile dice instead. In fact, while looking for games that use a D100, I found a one-page RPG by Alexander Kobayashi called Die 100 Times, which is such a clever name. And it's a neat system, so go check it out, link in the description. Anyway, for a more well-known example that uses percentile dice, Call of Cthulhu is a good one. An advantage of the D100 that the D20 doesn't have, to the same degree anyway, is that we understand percentages and fractions of 100 more intuitively than fractions of 20. If you roll a 67 on percentile dice, you know about how good you did as soon as you read the result. If you roll a 12 on a D20, it's less immediately obvious how successful you were, unless you're a nerd who plays too much D&D. Like me. Other systems only use the D100 for particular things. I know from my many hours spent reading the Dungeon Master's Guide that D&D uses percentile dice for its random tables quite often, like for wild magic searches if you're playing a sorcerer. Anyway, before I geek out about them too much, let's discuss how percentile dice actually work. Like I said earlier, and as many people already know, one of the D10s is the ones place, 0 through 9, and the other is the tens place, 00 through 90. When you roll them, you just add them together. 50 and 4 is 54. 60 and 0 is 60. 10 and 9 is 19. The only weird one is 00 and 0, which is 100. But other than that, it's a pretty simple idea. But what actually got me thinking about how they work in the first place was realizing that when you roll 2 dice and add them, you don't typically get an even spread of results, but a bell curve instead. Let's look at another common option for resolution dice, 2d6. When you roll 2 6-sided dice, there are 36 outcomes. For each of the 6 results on the one die, there are 6 possible results on the other die. So that's 6 times 6, or 6 squared, 36. Out of those 36 results, there is exactly one way to get, say, a 12, 2 6s. But there are several ways to get, say, a 7, 1 and 6, 2 and 5, 3 and 4, so on and so forth. You're more likely to roll a number near the middle because there are more combinations of results that will get you one of those numbers as opposed to the numbers at either extreme, which have fewer combinations. This results in a bell curve, where 7 is the most likely outcome, 2 and 12 are the least likely, and everything else falls somewhere in between. This is distinct from a D12 because on a 12-sided die, every outcome is equally likely. The fact that 2d6 gives you such a predictable bell curve is actually why some systems, like Powered by the Apocalypse, use it as their main resolution dice. It gently skews towards the average, making catastrophic failure and incredible success less likely, but more exciting when they do happen. So, do percentile dice have a bell curve? No, they don't actually, and you might see why already, but it took me a second to figure it out. Think of it this way. On 2d6, there are 36 combinations, but only 11 end results, 2 through 12. On percentile dice, which don't forget is technically 2d10, there are 100 combinations. For each result in the tens place, there are exactly 10 possible results in the ones place, so 10 times 10, 100. But there are also 100 end results, 00 through 99. Each combination corresponds to exactly one end result, which means that percentile dice do not have any kind of distribution curve. They are, in fact, completely fair, just like any regular die. This works because the two numbers you're adding together are different orders of magnitude, so no two combinations will ever have the same end result anyway. If you want to roll a 77, nothing other than a 70 and a 7 will get you that outcome. This is great and all, but what I find particularly interesting is if we extend this idea to other die sizes. It works really well with D10s because most of the world uses a base 10 numbering system, and percentages are second nature to us. But let's say you wanted to do it with D8s instead. If that were the case, grab 2 blank 8-sided dice, write 0 through 7 on one of the D8s, that's your ones place die, even though that doesn't apply in this case, but hopefully you know what I mean, and then write multiples of 8 on the other, so 0, 8, 16, and so on, making it your tens place die. And if you roll the two of them together and combine the results, because 8 squared is 64, you would get an even distribution of all the numbers from 1 to 64, as long as you treat 0 and 0 as 64, just like with percentile dice. Would you ever use this for anything? Maybe if you're making a stack-based Minecraft TTRPG, but other than that, probably not. You can't say it isn't a little cool, though. So yeah, that's how you would make a completely fair D64. Hell, I'm pretty sure, though I will have to test and fact check this for myself, that you could do this with any combination of two regular dice. Maybe that's what the next Dice Math video will be about, weird combinatorial possibilities. You ever say a sentence, and for a moment, you fully realize just how much of a nerd you are? Yeah. Anyway, that's my explanation of percentile dice in way more depth than anybody would ever need. If you enjoyed this video and want to stick around, you know what buttons to press to make that happen. Until next we meet, farewell, fellow travelers.